For centuries, comets have been enigmatic messengers from the outer reaches of our solar system, but one particular comet, 31 Atlas, has scientists buzzing. Its journey is unique, its composition baffling. Prepare to be amazed as we unveil the cutting-edge research and mind-bending theories behind uncovering where this incredible cosmic object truly came from. Our story begins in early 2025, when astronomers around the world got their first good look at Comet 31 Atlas. The buzz began almost immediately. This wasn't just another icy visitor from the distant outer solar system. No, something about 31 Atlas was different. It had all the makings of a truly special discovery. But before we dive into the captivating mystery of 31 Atlas, let me ask you a question. What is it about comets that fascinates us so much? Is it their unpredictable nature, their ethereal beauty, or the secrets they hold about our solar system's past? Let us know your thoughts in the comments below. Now back to the captivating tale of 31 Atlas. So what exactly is Comet 31 Atlas, and why did it capture the attention of the scientific community? Discovered by the Panoramic Survey Telescope and Rapid Response System, this comet was initially designated Pan-STARRS C 2025Y1 and later given the more catchy name 31 Atlas. But what sets it apart from other comets? Typically, comets originate from two primary reservoirs within our solar system, the Kuiper Belt and the Oort cloud. The Kuiper Belt is a donut-shaped region extending from Neptune's orbit at about 30 astronomical units from the Sun out to 50 AU. Meanwhile, the Oort cloud is a more distant spherical cloud of icy bodies thought to begin at around 2000 AU and extend as far as 100,000 AU from the Sun. However, 31 Atlas's orbit was not consistent with those of typical comets, suggesting a different origin story. Its orbit is highly eccentric, meaning it comes close to the Sun only every couple hundred years or so. But unlike most comets, it doesn't revolve around the Sun in a single plane with the planets. Instead, its orbit is inclined at an awkward angle, making it an extremely unlikely candidate for a native solar system resident. These unusual orbital characteristics immediately flagged it as an object of intense scientific interest. What are some other strange properties that make 31 Atlas stand out from the crowd? Well, its size is definitely one of them. Estimates suggest that 31 Atlas has a diameter of less than 1 kilometer, which is relatively small compared to some of the more famous comets like Halley's Comet. However, it's this comet's composition that truly sets it apart. Early observations indicated that 31 Atlas might be a dead comet, lacking the coma or atmosphere of more active comets. This suggests that it could have formed in a different environment, perhaps far from the Sun's influence. These perplexing characteristics left astronomers with more questions than answers. Where did Comet 31 Atlas come from, and how did it acquire such strange properties? Several hypotheses were put forward, each offering a tantalizing glimpse into the possible origins of this mysterious comet. Some astronomers believed that 31 Atlas might be an interstellar visitor, a wandering icy body that originated outside our solar system. Others suggested that it could be a remnant from the Oort cloud, a more distant sphere of icy bodies surrounding the solar system. Yet another intriguing theory proposed that 31 Atlas could be a Kuiper Belt object that became displaced and ventured too close to the Sun, altering its course forever. As the scientific community grappled with these perplexing questions, one thing was clear. Unraveling the mysteries of 31 Atlas would require a Herculean effort, a true scientific odyssey. Fortunately, the global astronomical community was up to the task. With dozens of ground-based telescopes around the world focused on 31 Atlas, researchers began collecting precious data about the comet's journey and makeup. Citizen scientists also played a vital role, their keen eyes scouring the skies for glimpses of this celestial enigma. As the pieces of this cosmic puzzle began to fall into place, a clearer picture of 31 Atlas emerged, revealing clues about its composition, trajectory, and ultimately its origin. Let's jump right into the nitty-gritty of the investigation. What were the first crucial pieces of evidence that emerged from these investigations? How did they point to a possible interstellar origin for 31 Atlas? Spectroscopic analysis of the comet's coma and tail provided the first crucial clues about its chemical makeup. This technique involves breaking down light reflected from the comet into its constituent wavelengths, revealing distinct features associated with specific elements and compounds. The analysis revealed a surprising amount of certain volatiles, substances like methane, ammonia, and carbon dioxide that are commonly found in comets originating from the Kuiper Belt or the Oort cloud. The lack of these volatiles suggested that 31 Atlas had not formed in the cold, dark recesses of the outer solar system. Instead, it hinted at a formation environment drastically different from our own. These findings were corroborated by telescopic observations of the comet's nucleus, its solid inner core. The nucleus of a comet is like its beating heart, containing the icy dust and rock that gives the comet its shape. Observations of 31 Atlas's nucleus revealed a surprisingly reddish hue, which suggested the presence of tholins, complex organic molecules that form under specific conditions. The presence of tholins lent credence to the interstellar hypothesis, indicating that 31 Atlas had indeed traversed the vast expanse of interstellar space, exposing it to the intense radiation that facilitated the formation of these exotic molecules. With these early pieces of evidence pointing towards an interstellar origin, astronomers were eager to piece together the bigger picture. The next question was, if 31 Atlas did hail from beyond our solar system, where did it come from and how did it get here? To answer this question, astronomers turned to astrometric techniques, essentially a fancy way of saying they tracked the exact movements of the comet across the sky. This involved meticulously charting its position over time, allowing them to create a precise map of its trajectory. By analyzing this trajectory, astronomers could reconstruct the path 31 Atlas had taken through space, hopefully leading them back to its point of origin. However, tracking the trajectory of a fast-moving comet like 31 Atlas was no easy feat. It required sophisticated instruments and complex algorithms to analyze the vast amount of data collected by global observatories. Nevertheless, astronomers rose to the challenge. Using state-of-the-art equipment, they followed the comet's path, searching for subtle clues that could reveal its interstellar birthplace. One key breakthrough came when astronomers noticed slight perturbations in 31 Atlas's trajectory, minute variations that could be attributed to gravitational interactions with objects in the outer solar system. These perturbations were like footprints in the cosmic dust, providing valuable insights into the comet's past. By studying these subtle gravitational influences, astronomers were able to refine their models of 31 Atlas's origin, bringing them closer to solving the mystery of its interstellar journey. As the pieces of the puzzle fell into place, a compelling picture emerged. All signs pointed towards an interstellar origin, mirroring the groundbreaking discoveries made with objects like Oumuamua and Borisov, which were also confirmed to be interstellar visitors. With 31 Atlas, the evidence was even more compelling, making it a prime candidate for an interstellar origin. The laboratory analogs are models designed to recreate the conditions under which 31 Atlas or similar objects may have formed. They serve as a critical tool for testing different formation scenarios and evaluating their plausibility. For example, researchers may attempt to recreate the conditions in molecular clouds where interstellar ice is known to form or simulate the gravitational collapse of a disk of dust and gas to form an icy body similar to 31 Atlas. By conducting experiments that mimic these conditions on Earth, scientists can investigate the potential pathways through which 31 Atlas could have formed. They can also analyze the composition of the resulting icy bodies to see if they resemble 31 Atlas in terms of their color, volatility, and other characteristics. This approach allows astronomers to evaluate the likelihood of different formation scenarios and narrow down the possibilities. Moreover, laboratory analogs are particularly useful when studying objects like 31 Atlas, which may not have formed in our solar system. By recreating the conditions of interstellar space, researchers can try to reproduce the chemical and physical processes that could have led to the formation of an interstellar comet. For instance, they may expose samples of interstellar dust to ultraviolet radiation or cosmic rays to see how that affects the formation of complex organic molecules like tholins, which have been observed on 31 Atlas. Through these experiments, scientists can gain a deeper understanding of the conditions necessary for the formation of icy bodies similar to 31 Atlas, and assess the plausibility of different formation scenarios. On the other hand, samples from other comets, such as Wild 2 or Ryugu, can provide comparative data to understand 31 Atlas better. By analyzing the differences and similarities in their composition and structure, astronomers can gain valuable insights into the diverse formation pathways of comets and their implications for 31 Atlas. For example, comparing the volatile content of 31 Atlas to that of Kuiper Belt comets can provide clues about whether it formed in a colder, more volatile-rich environment, like the outer solar system, or a warmer, drier environment like interstellar space. Ultimately, the combination of laboratory experiments and comparative analysis of other comets can help astronomers piece together the intricate details of 31 Atlas's formation history and shed light on its unique characteristics. Although we haven't yet retrieved samples from 31 Atlas itself due to its distance and speed, scientists are already working on the next best thing. They're designing and developing missions that will rendezvous with or sample similar interstellar objects in the future. These missions represent the next frontier in our exploration of the solar system and beyond. One promising concept is the Interstellar Object Explorer, a spacecraft designed to intercept and study interstellar objects like 31 Atlas as they pass through our solar system. This mission could involve a probe equipped with advanced instruments to analyze the object's composition, structure, and trajectory, providing invaluable data about its interstellar birthplace. Another intriguing possibility is a sample return mission to an object similar to 31 Atlas. By retrieving a physical sample, scientists could conduct in-depth laboratory analyses, uncovering the object's chemical makeup and formation history in greater detail. While these missions are still in the planning stages, significant progress is being made in developing the necessary technologies. For example, new propulsion systems and navigation techniques are being explored to enable a spacecraft to intercept and rendezvous with a fast-moving interstellar object. Additionally, sample return missions require the development of robust and precise instruments to collect and return a pristine sample to Earth. These technological advancements not only push the boundaries of space exploration, but also pave the way for future missions to explore the farthest reaches of our solar system and beyond. Understanding the origin of 31 Atlas provides a window into the history of our solar system and the conditions that prevailed during its formation. By unraveling the mysteries of this interstellar visitor, astronomers can piece together the events that shaped our planetary system's early years. Furthermore, a confirmed interstellar origin for 31 Atlas would have profound implications for our understanding of the frequency of interstellar visitors. It would suggest that objects like 31 Atlas are more common than previously thought, highlighting the dynamic and ever-evolving nature of our solar system. Moreover, studying these interstellar wanderers can provide insights into the exchange of material between star systems, shedding light on the interconnectedness of celestial bodies throughout the universe. Finally, confirming 31 Atlas's interstellar origin would underscore the remarkable capability of human ingenuity. The detection, tracking, and analysis of such a distant and elusive object is a testament to our scientific prowess and the relentless pursuit of knowledge. In conclusion, the scientific hunt for 31 Atlas's origin has captivated the imagination of astronomers and space enthusiasts alike. From its unusual orbit and composition to its possible interstellar journey, this comet has presented a tantalizing glimpse into the mysteries of our solar system's past. Through meticulous observations, innovative laboratory experiments, and the development of cutting-edge missions, researchers are piecing together the story of 31 Atlas. And as they delve deeper into its enigmatic nature, they bring us one step closer to understanding the birth of our planetary system and the wonders that lie beyond. Looking ahead, the next generation of telescopes and surveys like Vera Rubin Observatory will revolutionize our understanding of cosmic wanderers. By scanning the skies with unprecedented precision, these instruments will unveil new insights into the trajectories and origins of objects like 31 the Atlas. The scientific community eagerly anticipates the discoveries that await, knowing that each revelation brings us closer to unraveling the grand tapestry of our cosmic existence. So keep your eyes on the stars and your mind open to the extraordinary. The universe never ceases to amaze. Thank you for joining us on this journey of cosmic discovery. If you enjoyed this video, don't forget to hit the like button and subscribe for more updates on all our latest videos. Until next time, keep looking up and exploring the wonders of our universe.